Go ahead, Cynthia, whenever
Well,
you're ready.
welcome to all of you. We're so excited to have you with us for what we affectionately call a party with a purpose. And normally when we do a party with a purpose, we try to get together, but having this crowd and having Sebastian, we're doing it via Zoom. It's a party, but it's also got a real purpose. The purpose of when we started this was to really showcase some really incredible people that we have in our community. And Sebastian, you are going to be blown away by Sebastian Zimmeck. And I will tell you right now that right after this, we will be sending out his bio, which is too thick for all of us to comprehend. And I don't know how you got as many degrees as you got, Sebastian. But the purpose really is to talk about relevant things that will help us all as we move forward, either with our nonprofit organization, with our daily lives, or with our business applications. So Sebastian is there to help us with that. So number one, this is being recorded. Number two, we will be sending out Sebastian's slide deck at the end of this, plus his bio. Number three, Thayer and Abby and Mary will be monitoring the chat box for questions, but Sebastian is really willing to take a raised hand and start answering those questions. So it's going to be a give and take. So questions as we go along. Sebastian, thank you. I just will do you justice with just a little bit of your bio. Sebastian is the assistant professor of Wesleyan's Mathematics and Computer Science Department, and his research and teaching interests are to inform us on privacy and security issues. I'm telling you, you have a postdoc you got your postdoc at Carnegie Mellon's Institute for Software Research. You studied computer science at Columbia University with a PhD and an MS. You are a Google Research Fellow. I could go on, but I don't want to. So one of the goals of today is to find out the history of AI, how all of a sudden did we not really know about it, and why did it explode? What is it? Why AI now? And how does, just some basics. How does AI not make mistakes? Who monitors it? Who owns the stuff? So Sebastian, with that, take it away.
Yeah, thank you very much, Cynthia, and also Thayer and the whole team for inviting me here. It's a pleasure. We were just talking a little bit about the Middlesex community and the foundation here, and I think it's great, that such a place exists. And so, when you contacted me, I thought that that's a great thing, as I understood it at the time. I understand now even more after your explanation, and so it's great, to be here with you. And I want to echo a little bit, what you said, Cynthia. So if any one of you has a question, right, then please, raise your hand, or, in other ways, do let me know. We should have a discussion of the things that interest you, instead of me holding a monologue here about what interests me, right? So I think, the hour would be much better used, if I hear from you what you would like to know. Now, that said, let me share my screen here, so that I can share my slides here, and we will receive these slides at the end of the talk, or sometime later. So first thing to note here is this fantastic title, which I did not come up with. AI 101, the myth, the legends, and the everyday. So that was developed here by Cynthia and her team, and I try to do my best to fill out these promises here in the title. Just earlier today I saw there is an executive order today outlining the federal government's first regulations on artificial intelligence systems. So that's a constant theme, I think, that we will see over the next couple of years, that the technology develops in some direction, right? And then we have a response, from the legal community, from the regulators, from the lawmakers. because we need to deal with this, right? We need to have rules in place for these new technologies. The first question for me is, how did we get here in the first place, right? It's not that sudden, actually. I mean, it seems sudden, but AI has some history, and actually started, I would say, in 1770 with what is called the Mechanical Turk. So the Mechanical Turk, maybe some of you have heard of it. What is it? Well, this was presented as a machine that can play chess. And what it really was a little human sitting inside a box and making chess moves, right? So it wasn't really, artificial intelligence, but rather human intelligence. Now, the fun fact is that we still have a Mechanical Turk today. There is the Amazon Mechanical Turk. And that actually has a connection to machine learning. And maybe some of you heard about it. What is the Amazon Mechanical Turk? Well, that is also what they call artificial intelligence. So human intelligence, actually, but we use it for real artificial intelligence. And I will come back to that point later. How do we make use of that? So 20 minutes, give me 20 minutes, and we will get to that point. Then I would say the start of the really modern AI movement was in the 1950s. Alan Turing is famous for many things, one of which is the Turing test. So here the question is, for example, how do we measure whether a machine is intelligent? And so that depends on our definition of intelligence. And the way Alan Turing formulated it is that we perceive from the outside, does a machine behave intelligently? That is our measure for intelligence. We cannot look into the machine, so we have to tell from the outside. And the Turing test specifically makes the claim that a machine is intelligent if a human cannot distinguish the behavior of the machine from a human. So we ask the machine a question, and it responds through a closed door, maybe. And if we cannot tell as an observer, sitting in front of this closed door, whether these answers come from a human or from a machine, then we would say, okay, this machine has passed the Turing test, and is therefore intelligent. And so the 1950s, I saw a 1956 conference, the Dartmouth College Summer AI Conference, and at that time, the leading researchers on AI got together, and they said, all right, let's spend one summer and let's resolve this, one time and for all times, right? Like how can we make, computers intelligent? Turned out it takes more than a summer. But that was kind of the modern, starting point. Not much happened really after the 50s. 1980s saw what we call now expert systems. So very domain-specific systems that behave somewhat intelligently. So maybe for accounting or for architects or doctors, systems that help experts doing their job. The rise of the internet and the data in the 1990s now led to what maybe could be called the first really explosion of intelligence in our modern times, and we will see why data is so important here. That's also the time when machine learning reemerged. So AI, machine learning, we have all these words. I think we need to clarify also a little bit, what they are, and that's what I will try to do in the next couple of minutes here. Generally, where we are now is the broad use of what is called neural networks and large language models. And so these are also machine learning technologies, and we'll also clarify a little bit, what they are and how did we get here. Okay, so that's kind of the stage, set for us. The AI revolution, why now? Maybe even 2 years ago, it didn't seem so urgent and so impressive, what was happening with AI. Why did we have suddenly this breakthrough? I would say three things came together here. First of all, we have the data. So if we want to use artificial intelligence, we need a lot of data. We did not have this. We had books, we had newspapers, physical items, and they were hard to process for computers. And now, with the web or more broadly internet data, we have this data in a computer processable format. And we will see why this is so important. Secondly, we have advances in what is called hardware or compute. So, if you think back of the 60s, we didn't really have something like data centers or cloud computing. Every company that wanted to do computing had what is called a mainframe, like one big computer that they have in their own building. And now we can actually rent these kind of computers from Amazon or Google. They have their cloud computing infrastructure, and all of us can get it. We can get this, computing capability for much less than buying in the 1960s this big computer, right? Secondly, or thirdly, we have advances in the software. And in particular, the big companies and many smaller ones, they make their software publicly available. They are machine learning models. And they are not proprietary, but rather they are provided to the public, and many of us can use them, for modest amount often case. And so these three things, they were long in the making, but they came together in this, sort of pivotal moment, maybe a year ago. So let me clarify some of the terminology that you may hear and that we'll be using here. So first of all, the term AI, artificial intelligence. What is that? So let's maybe take a step back and say what is even intelligence? We already learned a little bit the definition from Turing, right? Turing said, we say something is intelligent if it behaves intelligent from the outside, right? And that is really a definition that is based on the fact that we cannot be another person. We cannot be a machine. We cannot be a bat or a dolphin. We are just us, right? And from our perspective, as far as we are concerned, maybe everybody else is a robot, right? And we cannot be the other person. So we have this fundamental problem, which is called the mind-body problem. And so, intelligence is hard to define, and we will actually never know what intelligence really is. We can measure some correlation. For example, in the brain, certain, activities trigger certain neurons, certain areas in the brain. And so this can be correlated. But we cannot perceive this as the other person, right? And so that's a fundamental limit that cannot be resolved. And that's why Alan Turing came up with this very practical definition. Okay, we look at it from the outside, and we call it intelligent. If it seems to us from the outside, it is intelligent. That is what is called weak AI. And that is different from strong AI, which is consciousness, rational thinking, empathy, right? These are things that we cannot measure from the outside. And so at least when I talk about AI, I refer to weak AI. I don't think computers are thinking as we do as humans. I don't think that's the type of intelligence that they have, but rather they're processing data to make useful information. That is, what I consider here artificial intelligence. Artificial intelligence is sort of the umbrella term for all kinds of intelligent behavior, any technique that enables computers to mimic human behavior. So looked at from the outside, looks intelligent. That's, AI. And now the, interesting part of AI is machine learning. That's a subfield of AI. And so machine learning means that we don't explicitly tell the machine do X, Y, and Z or follow rules 1, 2, 3, but rather we give the machine data, right? And that's why the availability of data is so important. The availability from the web or the internet more broadly. We need to tell the machine, here is some data, and this is what this data means. That's what we need the data for. And then finally, these, most advanced forms of artificial intelligence, part of machine learning, like ChatGPT, they are based on deep learning. So they are based on finding patterns in the data that is presented to them and then generating new data from it. And so we have this broad artificial intelligence scape with machine learning as a subfield and then deep learning as a subfield. And that's, where currently, the action is happening. Here is some data, from my own research. And this gives you a glimpse of why a machine might be able to make sense of data. So this is people's ethnicity measured in New York. So we see, Manhattan here, part of Queens. And the blue parts and the blue dots is an African-American person. As you can see, for example, there are more blue dots in Harlem than they are in Manhattan, like, the central part of it, right? Let's say maybe the Upper East Side or the Upper West Side or Queens. And so if data is distributed that way, right, it is possible for a machine to learn the structure of data. And, as you already also can see here, there is potential for problems already in this data, right? If we have things like ethnicity, which is highly sensitive data, a machine actually might learn to discriminate against people, right? It might learn here to do, for example, housing discrimination, right? And so that's the reason why we need to be also very careful with the application of artificial intelligence, because if we are not, we might end up in a modern place of, redlining, for example, right? And so what has to go hand in hand here is the technology, but also the regulation and also, the safeguards. And so that is, what we also need to consider here. As I said, artificial intelligence is a very broad term, and in a very basic way, you can see it. All right, we just make rules. When X, then Y. Right? It's a very basic rule. It's always if this, then that. We can do that, and this is intelligent. This is also called heuristics, right? These are approximations of intelligence, I would say, but we can do better. And here is one little example that I want to show, to motivate what is machine learning, right? We have rules, okay, we know that, but how can we do a better job, right? And so if you just look at this graph here on the left side, right? Let's just assume, okay, at the bottom, like at this, x-axis, so we have 6 units there, 0, 1, 2, 3, 4, 5, 6, right? And let's just say this is time, let's say 1 hour, 2 hours, 3 hours, and so on and so forth. And then the y-axis, so on the left side from 0 to 4, we have maybe the outcome of a test. And so, what you would think is, okay, if you study longer for a test, you would get a better outcome. You get a higher grade. The longer you study, the higher your grade will be. And so here what we have in these, 5 blue dots that are shown on this graph is, this is a distribution of students who studied for a number of hours and received their grade. And so, for example, the leftmost dot, the student there studied for 1 hour and they received a grade of 1. So this is the lowest grade. Then we have another student, they studied for 2 hours and they received a grade of 2. So, direct payoff, right? And, you see where this is going, right? The longer you study, the better potentially your grade. That's not always true. Maybe somebody studies very long and, still cannot get it. Maybe it's not their favorite subject, right? And so they don't do quite as well. Or maybe somebody already knew a lot beforehand. They don't need to study as much. So this is not like a hard and fast rule, right? But the tendency is always the same. And so what we can see here is, if we give a computer these data points, right? And you say, okay, can you come up with a line, that closely matches these data points as good as you can, right? Can you do that, right? Then the computer will come up with this straight line and will try to minimize the distance between each point and the line. And that is really what machine learning is about, right? We don't tell the computer exactly, this is the rule, and, if X, then Y, but rather we give the computer a number of data points and say, look at this data and, make a function, right? And kind of draw, the best that you can, right? That best matches this data. And that is really what machine learning is about, right? It's a change in paradigm. It's not us dictating, why, how you should see this, but rather the computer figures out with our help, what the structure of the data is, right? And so once we have that function, now here comes the machine learning part, the actual interesting part, the prediction, right? Now, if we get a new student, right? Let's say the student studied for, let's say 6 hours, right? What would the machine predict? Well, the machine would just, continue drawing that line and would say, all right, the student probably received a 3.5, in that test, right? It's a prediction. It's something new that did not exist, right? So it kind of extrapolates from what we trained it towards a new item. And so that, that is really the power of machine learning, right? We give data and then the computer says, all right, let me give you a new prediction for something that you want to know. Okay, if you have any question about this, please do let me know, but this is the basic principle, right? And so now, we can, talk about different types of tasks that you can do. You can classify animals, for example. You can say, okay, you just tell the computer, here are 1,000 pictures of dogs and here are 1,000 pictures of cats. Computer learns what are the differences between these. Now, tell me, is this new picture that you see, does it have a cat or a dog, So that is, for example, what is called classification. And so there are different types of machine learning tasks. What we just did is called supervised machine learning. We sort of teach the computer. We give the computer data and say, all right, here's some examples. You just understood, grades, right? Or cats and dogs. And now, we give you an unknown example and you tell us, right? What is it? Is this more cat or more dog? Interesting fact, maybe these little, captcha challenges when you try to log into a website, right? And you need to say, identify all the bikes, identify all the cars, right? That is actually being used for machine learning, so we are sort of, abused to train a computer to identify, how do cars look like? How do, bikes look like, and so on and so forth. So this, we have different types of techniques here, supervised, that we just said, but we also have unsupervised, where we just give the computer some data and say, all right, try to understand the structure of the data yourself. We don't give you an explicit definition of what a cat or a dog looks like, or, one example here. And so this is really where that data comes in. And so we train the model based on that, train the machine, and then we test it on a very small subset. So we actually try to say, all right, did the machine do a good job of identifying cats and dogs, right? We do this maybe with 100 pictures. And if they can do it with 100, we are convinced they can do it with thousands. They can do it with 1,000,000, right? And we don't have to check anymore. And so that is what the testing is for. Okay, lots of applications and domains for this, right? Can imagine, vision, that's important for autonomous driving, right? If you have cars, right, that should drive you, okay, we need to be able to see And then we need to be able to tell, all right, that's a car, that's a human, that's a cat, that's a dog, that's a bike, that's a boat, right? And so on and so forth. Sensing. So, maybe, we have to identify whether, we hit a small fly or, hit, a human, right? Or something like that, right? I mean, we basically understanding, our human sense, how that could work, for a machine. And maybe the most prominent one, language. We as humans, we communicate through language. And so, that for me as a computer scientist is really the fundamental problem. On one side, we have the computer. On the other side, we have us. And so now we have to have a common language so that we can actually talk to the computer. If you want to really see it that way, I think ultimately all the problems that, I would say computers have with people. I wouldn't say it's the problem of the people. It's, we should make computers work for the people, not the other way around. And so ideally, computers should understand us, right? But we speak different languages. And so how can we put these together, right? That's the question. And that's something that we can try to solve here also with machine learning. Many domains, as we said, driving, earthquake detection, writing essays, language, right? The use of language. Write me an essay about, the American Civil War or something like that, lots of applications and domains here. And what I think, has taken really the biggest impact in recent months is what is called large language models. And so these are deep learning models. And so what they are, I give you a small definition here, are general purpose machine learning models that are pre-trained and can then be fine-tuned for specific domains and applications. So general purpose machine learning models means they can try to write an essay for us. They can also try to answer a question that we have, right? This is not specific to any kind of domain or any particular task, but rather their general purpose. And they were trained for general purpose. Many of these models are trained on basically all document that is available on the web. And so they have a general knowledge, but we might also to fine-tune them for specific tasks. So, for example, if you want to help them help us in the sense of medical diagnosis or something like that, right? Then we need to train specifically with medical data, and then experts need to look at the data that was given there and actually say, this is a correct diagnosis, this is a wrong one, right? So a machine learning model or large language model, it has a starting point that it knows generally what's available, for example, on the web. But then we need to, if we want to have it for a specific purpose, train it specifically for the domain that we want. And here are some of the ones that you know. So these are general purpose large language models, GPT-3 or 4 or BERT or ChatGPT, and so on and so forth. And you might think, all right, there are suddenly 1,000 apps, they have all these machine learning models, but it's actually really the way, and that's why I write wrappers here, that they're not that many. There are a handful, maybe 10, 20 general purpose models, and then apps that use them, right? They are based on these. So it's not the way that everybody has their own model, but rather it's the way that we can use them, and maybe we train them then for specific domains, right? But the underlying model is really the same for many of these, right? And that's what I call wrappers here. They get their data from the web. We already said it. Many other domains. Who is creating these training data sets? In my own, research, what we often do is crowdsourcing. If you're interested in distinguishing between cats and dogs, all right, you come up with a number of pictures. you hire a number of people and they label each picture, is this a cat or a dog, right? At this point, we are so far that we actually need experts to label data. So these are like medical experts or chemists, you know, because we are so specialized now, right? If our machines should be as good as the expert, you know, chemists, then we better train them using expert chemists, right? And so that, you know, these are the people who are creating the data sets. So just, you know, two more things here. If you see, you know, these items, few shot learning or zero shot learning, that just means basic model with very little, you know, additional training data. Now,
Sebastian, can I jump in really quickly
yes,
with a question?
Yes.
We were talking earlier, and I think it really touched in what you were just talking about with where a lot of the data comes from. Early on, when Alexa and some others were just hitting the market, people were worried about having them because they monitor in their houses all the time. We know our phones and our Apple Watches do, because we all will then go out on our social media, and the ads all seem to be exactly what we were talking about. I guess my question is, are they really monitoring all the time? And is that where a lot of the data is coming from, as it's cycling through and learning? And learning, I guess, is.
Yeah, that's a very good question. You know, I have to disappoint you because I cannot give a general answer to this. You know, I think what we are seeing at the moment is a little bit on the company's part is ideally they would like their models to be trained on any data that is made available, right? And you know, we had this, for example, also with Zoom, right? Can these recordings like ours here be used, right, to train these models? And initially, in the terms of service with Zoom, it said yes. And you know, the same is true, you know, for Alexa and, you know, Siri and, you know, all these other, you know, intelligent assistants. What do their terms of service say? That's really, you know, what it comes down to. And so, you know, the law does not prohibit companies from using this data, but it should be in an agreement with the consumer, right? And so I think we are on the path of developing a consensus towards, you know, what is acceptable here, what is acceptable training data, and what is not, right? So you know, my understanding is, for example, the Zoom data is not used now for training purposes, right?
And it's so interesting you said that, because they do have 2 new AI components, and I don't know if you've ever looked at them, but that is true, that when you go to read what they're about and see if you want to enable it, it says that they're not using them to train their AI or any other third-party AI model.
Yeah, absolutely. So I would encourage you, maybe practical advice if you're concerned about that. Yeah, unfortunately, you have to read the terms of service. You know, maybe you don't need to do this for all, you know, all the things that you use, but maybe those that are particularly important for you, then, you know, you can look at it. I would err on the side of assuming that it is used for training. So that means essentially, you know, these models, they're so data hungry, right? And I mean, from also employment perspective, right? If you work at a company or organization like yours, right? If you put, for example, data into these models, you know, as a user, right? You say, all right, here is some document, you know, make that nicer for me, you know, write that better, you know. Okay, then, you know, this becomes part of the model, right? And so you have to be careful with proprietary information. So this can be like sensitive information on a personal level, but also proprietary from a company level, right? And so you would need to be a little bit careful, you know, what data you allow the model to connect, and, you know, what you also give it, you know, to the model. It's not that the model will forget it, right? It will become part of it. And so that, you know, I would encourage, you know, especially those of us who have, you know, sensitive data or feel, you know, maybe on a personal level, I don't want to disclose this, right? That you take care of this. Yeah.
Great. Thank you.
Any more questions? Maybe. I mean, you know, I feel
We actually have a couple that may tie into this. So
bring it on.
One really good question. We all are familiar with human cyberbullying, but could potentially, that means we're presuming you could teach AI to actually bully and mimic that behavior, and what does or could potentially prevent that as we're exploring the realm of AI and what it can be used for?
That's a very good question, and it's not only theoretical, but it actually does, have some precedent. Microsoft, I think this was 2016, so it's a few years back. They had a chatbot early on, and they turned it on, and after a few hours, it started to make offensive comments, and the reason was that people trained it that way, right? They just had input into the model that made this model recognize, all right, this is how humans act, right? So I'm going to act that way, right? And a few hours later, Microsoft turned it off because they couldn't know, they didn't know how to stop it, and that actually caused, for example, Google to be relatively careful with this, because they had the technology but decided, all right, we want to be a little bit careful here what we make available to the public to avoid exactly this kind of problem that you just described, right? And so what are the ways of preventing a model from making offensive content, for example, right? Or cyberbullying, for example, right? And the essential way is that you try to give it examples of offensive content, right? And then say, all right, if somebody, for example, makes a query, makes a prompt, right, to swear or something like that, that you identify it and you actually don't return an answer, right? Because that would be a prohibited use of the model. So you try to teach the model what it can answer and what it cannot answer, right? So that would be one way. I think we are fairly early on in this understanding of how we can prevent that, but essentially we need to have the model identify itself, what it can answer and what it should not answer.
There, I think you had a question from Kathy Weiss.
Thank you. Yes, Kathy, I saw you had your hand up. Did you have something you wanted to ask?
I had 3 questions based on what you just taught. So the first is, you mentioned the Chat GPT and all of the BERT, and what are the best sites AI for nonprofits? And if you can, you said, I really like your line about the computer should get to know you. I've been using Chat GPT for some routine tasks for my nonprofit, and as a guide, as a time saver. And I give it the LLMs that I want. For example, so what are the best ones for the chat? What are the best AI sites for nonprofits?
Yeah, that's a very good question. I would say the best AI tools for nonprofits are the best AI tools. I think I realize that sounds like a non-answer, but maybe let me say a few words about that. I am not aware that there is one specific AI tool that is particularly good to use for nonprofits. And so my sense is that probably you are best served with what generally is the best, right? And so the ones that you just said, right, these are the the standard ones, like Chat GPT, Bing Chat and BERT, and these. So that would be my starting point. Maybe at some point somebody would have an AI that would be particularly good for nonprofits. But for that to happen, we would need to train it specifically for that. And now I'm not in the nonprofit world, so I couldn't definitely say this does not exist, but I would think it does not yet exist. And so what you would be using would be these general models, right? These out of the box models. And for those, it depends
But you can train them to get to know you. You can say, this is my style of writing. This is how I like to write. This is me. Now I'd like you to give me 500 words in this kind of style. Or I can say, heartfelt. I would never send it as is, but it just saves an enormous amount of work sometimes.
Yeah, absolutely. Absolutely. And so I would say, try out the standard ones, and you already said you're using the, ChatGPT, and maybe you're satisfied with that. Maybe compare it against another one. I mean, I'm aware of there are like specific ones. I think one is called Hemingway or something. I guess it turns every writing that you do into kind of Hemingway style of writing. If it happens that this is your style as well, then maybe use that. If that's not your style, probably it's not so good.
Well, thank you. Thank you.
Thanks, Kathy.
Any other questions, maybe?
So I'm sure that, because somebody asked this and we were already talking about it. I'm sure this is on lots of people's minds, especially particularly because you're at Wesleyan University. So what does AI mean for critical thinking and critical questioning if students can actually just say, oh, instead of let me think about that, let me ask AI that?
That's a great question. That's that's something I always wonder, and I have a thought on that, but maybe I will pose the question also here to our participants, right? I mean, do you have a thought on that? What is your thinking? I mean, do you have suggestions maybe for me? What could we do to keep up this critical thinking, right? Because we could just say, all right, we just ask the AI, and whatever is returned, we just accept, right? I mean, that's the AI is so, powerful, much more powerful than us and much more experienced, right? It knows the whole web, so that must be right? I don't think that would be a good development, but yeah, what could we change about that?
Well, is there an opportunity for debate or conversation about a particular topic? Even if some student had submitted something written by AI, I mean, challenging the student body to discuss and defend a point of view.
Absolutely. That should happen. And so maybe an assignment could look like, okay, ask your favorite, AI model this question, right? And then, discuss it, right? And okay, if we wanted to be sure that the student is really doing that, maybe we need to do an oral exam or something like that, right? So that the student comes with their AI generated answer, and then, maybe we ask questions or discuss this, right? Absolutely. So that would be a practical, solution.
So we have a lot of folks in here. Some are from business, some are from nonprofits, some are just curious. But we're doing the Community Foundation folks are doing all the talking. So no questions from anybody out there?
Don't be shy.
Right, please. You're amongst friends. So I have another one, and it's from the Community Foundation's perspective, and also I think and this came in beforehand. So do you see AI improving grant writing and grant applications, and the processes? And the person who submitted this used particularly private foundations and also government and at the federal and local level, or state level rather. So do you see that application for AI?
Yes, I do see it. I wouldn't say, maybe you can tell me if I'm wrong, but I think, grant writing is not some, writing that is totally different from other writing. And so in that sense, absolutely. And maybe let me pick up the previous question that we discussed, right? Probably what you don't want to do as somebody who is in the space, you don't want to have your grant documents completely written by the AI, right? And then, just accept it as it comes back. I think that would not be a very good use. But, what I think will happen is that we as humans will be in a different role. And that is a role that we need to train in school here at Wesleyan and at other schools. But that's also a role that we encounter in grant writing, that we encounter in other professional writing capacities. And that is the role of a supervisor. We will have still our critical thinking and, our human intelligence, right? But ideally, all the standard tasks are done for us by the AI, and then we get back that writing. In this case, maybe this grant proposal, or maybe even the decision about the grant, right, and how it should be formulated. The arguments why a certain proposal was accepted or not accepted. But then we as humans need to take a look at it and say, all right, does this make sense to us? Is this argument sound? That is still the job that we need to do. And so I think it can save time and can maybe even point in some directions we have not thought about it, but it will not relieve us from our supervision of the machine. And so I think that's not only true for grant writing, not only true for school, that is true, for any kind of writing or any AI task. In fact, you want to think about it, self-driving, autonomously driving cars, it's the same thing. The AI will probably mostly drive us, but then we still need to have a level of supervision, right? And so we will not be relieved from this. It's just our aspect of what we need to do changes. Our dimension here changes.
Kathy?
Yeah,
I'm sorry. Go ahead.
I'm trying to unmute.
I can hear you.
Oh, okay. I have the perfect example of that. I've worked with expert systems in radiation therapy in the 1990s, and I would never just put the patient on the table and just let the machine move all around and then turn it on, because it can be a tool to double check you, but if there is some room for error, and it's really basically what you put into it. Because I wrote an expert system once, and it's just very boring. You have to think of every possible, concoction. And so it is the person writing it. So that's, I think, where the critical thinking comes in. When you put your parameters in, go to something more simple like a thank you note. You can say the parameters and use as a guide, but you can't, there's no heart and soul in it. You have to look at it, and you get most of it, but then instead of spending, maybe 25 minutes on it, you're spending a few minutes on it, which is a time saver, but you have to put your heart into it. I would never send it the way, it puts it out. You can put parameters like this thank you note is for, a certain type of donor. It's for that type of donor. It's for, things like that. I mean, so I think that's where the critical thinking comes in. That's where the supervision comes in. That's what I really understand what you're trying to say.
Mm-hmm. Absolutely. I think you make a very good point here. And I see, I think Natalie also has a question on that, or maybe a new question.
Yes, maybe just a comment. I have attended another session that the Chronicle of Philanthropy did with professional grant writers that talked about the use of AI. And to the prior person's point, I think they were talking about the use in technical writing, where it's technical details that can be extremely helpful. But from the point of view of empathy and local knowledge and the personal story and those pieces that you often use in a grant application, those are a little bit more hard, or a lot harder to emulate.
Absolutely. It is a tool, but we cannot blindly rely on it. So that's the good news about that is, I think the claims, oh, we will all be out of jobs, the AI will do all of us, the things that we do now, I don't think that will happen. I think what will happen is the type of job will change. Hopefully we all become more effective using the AI, relieving us from, kind of work that we don't necessarily need to do, like what Kathy said earlier with putting in the heart and soul into a letter, right? That's what we are good at, the humans. But maybe there are other aspects, like maybe writing out the addresses for the grant letter, right? Okay, that doesn't necessarily need to be us. That can be done by a machine, right? And so I think that is, where this is also going with the jobs, right? That our jobs will change. The activities that we need to do will change. Just as a pilot is not flying all the time the plane, right? They push a button and then, okay, these 1,000 miles we just fly straight, and then when it gets to the landing, then we need to land. It's actually the pilot's job, right? And so in that sense, that will be our job, right? So I'm also not too concerned about that, for example.
So I'm actually going to make a suggestion, because we can always jump back. Sebastian, I was going to stop sharing your screen so that people could sort of see, and then I'm going to put somebody on the spot, because Ethan has been so polite and he didn't want to jump ahead in your presentation and ask a question that you hadn't gotten to yet. But he's been so good because he keeps sending me messages. So Ethan, I'm going to put you on the spot and say, go ahead and ask your question.
Okay, Thayer, thank you. Sebastian, first of all, thank you so much for your time. I'm so enjoying your presentation and your insights. I think just in the sort of to react to a bit of what we've just heard in the last few minutes, I think in the context of an educator, it's a real challenge with ChatGPT, and plagiarism is thousands of years old, and I think as an educator, that's something that you need to that educators need to in general monitor and use common sense and challenge, because in the context of critical thinking, as part of education, ChatGPT, in my perspective, is a shortcut. I see, first of all, just in terms of, I played around with ChatGPT, from a hobbyist perspective, and not really for my business, and also have enabled AI for my searches, Google and otherwise, and I've found it to be incredibly useful and insightful and helpful. So not fearful in that perspective, and with regard to medical applications, whether it's medicine or pharmacology or radiology or so many different other aspects of human health, I see incredible benefits here. But I want to take a huge jump to a 180-degree perspective and say, and I put you on the spot here, the Terminator scenario, that's somewhat not out of the realm of possibility. And so I'd love to hear your perspective on that. And I think that speaks for itself. I hope I don't have to further define what that means, but what's your perspective on that? Thanks, Thayer.
You're welcome. Thank you.
Yeah, I think that's a great question. I let me just start by replying a bit to what you said earlier in terms of the education and in terms of homeworks, for example, right? I think largely the onus there falls on the educator to design homeworks in a way that are sort of GPT proof, right? Where we actually mirror what is happening in the real world, what will happen in the real world, the supervisory role, right? And one small anecdote maybe from my current class, I thought about, okay, what do I do? Should I say you cannot use AI, or should I just allow it, or something in between? And so what I did was I just said, all right, use it. You can use it however you like and what you like. And I was worried, will I have 100% A pluses in my class? Turns out it's actually not the case, because when the homework is complex enough, it cannot be done by the AI. And so you actually need to understand what you're doing to effectively use the AI. That is the only way to resolve this homework. And so I think that is also what you encounter in the real world. And so the school should mirror and should prepare for that. So that is, my general answer to the, education aspect here. I understand that, many subjects, that may be more difficult than in others. And, you need to think about how you exactly, you're going to do that. But I think that is, that is the core that we have to find out, over the next couple of years. On the second part of your question as to this Terminator scenario, so in the sense that, okay, we have so intelligent machines, and now they might take over the world, right? Or they are so much faster and they have so much more knowledge than we are, or than that we have. And I'm not sure if I'm the most qualified person to speak to that, but I would say my sense is that it doesn't seem to me that the AI would sort of develop a life on its own in the way that we cannot control it anymore. What may happen is that, okay, there might be the situation as with the chatbot that sort of went rogue, right? But then we have to pull the plug, right? And stop it, right? And I mean, okay, then you could say, yeah, I mean, this very intelligent machine will, kind of expect that and, try to prevent it. But I mean, at least I have yet to see something like this happening. So it doesn't strike me as particularly, realistic that an AI that is, ultimately based on human knowledge and human programming, could sort of rise, and go over that boundary. I mean, fingers crossed. That's I would say that.
John Bittiscombe, I think you had a question. Hang on, he's unmuting Sebastian. Hold on. There we go.
Yeah, Sebastian, at a university or in an educational setting, and that institution really treasured their honor code, and faculty agreed to continue the honor code in relationship to AI. Why wouldn't that exist in terms of why wouldn't that protect some of these issues that have come up about how you decide whether the content is being an outside source that is not recognized in your recognition of the sources you used?
That's a very good question. And I have to absolutely agree with you. A student or anybody who honors the honor code, right? We would not have that problem, right? And, there are, I would say, the vast majority of students who do that. But still, there are also some who don't. And in some ways, it is a little bit then the individual, who needs to make that determination. Do you trust, the student body as a whole enough that you have maybe around the edges, some irregularities. And I personally, I fall more on the side that I usually don't rely on mechanisms that I cannot enforce. And so the honor code I cannot enforce. I mean, that is it is there, but I have no way of making sure that really 100% of the students are following it. And so maybe I think what you're describing is more a general tendency towards how do students see the honor code, right? And to have the honor of not cheating. I don't think this is anything specific related to AI, but rather this is generally maybe something that we need to instill in the students, right? That is something important that you have to adhere to. but that's not something we can technically enforce. And so I think it depends on where you stand on, okay, how strong do you want to have a technical enforcement of that honor code?
So Ethan, I have gotten two questions, or Ethan was asking the question. I looked up and his name was in front of me. Sebastian, I've got two questions that are almost identical, and I think there are probably others. We've heard recent reports in the news that some tests on AI learning have found where it's been making up answers based on trying to answer a question. So there seems to be a lot of questions about how can one distinguish truth from disinformation, or how will we know that the AI is differentiating between misinformation, disinformation, and factual information?
That's a very good question. And I think, I think that is very hard. I think there is no sure shot way to make that determination. And that is exactly where we come in. So this will be our judgment call. And, I think it is even a little bit more difficult because the AI often sounds so convincing, right? It speaks clearly wrong information, but with a conviction that a human often does not have, right? And it happened to me many times, or not many times, but few times, where I asked something about something that I knew for sure, and an AI gave back the wrong answer, and I realized they are fairly submissive, actually, because when you then tell the AI, hey, it's just wrong what you just said, it is rather like that, then the AI always told me, oh yeah, you're absolutely right, sorry about that mistake. But before that was with a conviction, right, that it made this claim that even this style of answering seems pretty convincing, even though if the answer is wrong. And so I think at the moment, unfortunately, we would need to say, all right, we have to look at this and we have to make up our own mind. Is this real information or is this disinformation? Ultimately, the AI can only produce new results based on the results that we give, and also based on the quality of the data that we give. If the quality is bad, we cannot expect good results. If the amount of data is not enough, we cannot expect good results. And so it all depends a lot on the inputs. And if they are what they are, we cannot expect more from the AI to somehow magically, make more out of, what the underlying data is. And so the answer, I think, is maybe fairly disappointing, but we still have to think and make our own judgments about it.
Cynthia, I think that, did anyone else see any other questions? That ran through my questions so far that I have.
I have a quick one again. I just
Sure, John.
Yeah. Why can't the AI be trained to monitor itself so that misinformation could be, when submitted, could be back or like checked against another AI response to a similar, saying that, well, that wasn't your own work, that was AI's work.
Mm-hmm. Yeah, I think both of these things that you just said, these are interesting ideas, and maybe it could be. So the one thing, could an AI, itself sort of check whether it's something misinformation, and maybe you can even try it. I haven't tried it. Like maybe you give it a piece of information, maybe an article, maybe one that you just made up, and you say, all right, is this true or is this misinformation, right? How good is that, right? Some principle, yeah, that could work. And the second point that you said, maybe you ask another AI, right? And, that checks the first AI. And you can do this even on your own, right? If you're maybe not sure, maybe you could use multiple AIs, right? And sort of at least get a gauge of, okay, what was responded to you, right? Are everybody at least going in the same direction, right? I would still not 100% rely on that, because I still think in the end, there needs to be a human in the loop. But I mean, yeah, these could be these could be, useful ways. I think a lot of this is not completely researched out, maybe not even, scratch the surface, right? I mean, we are, at a frontier, in some ways, in all of these things. And so I think, the question that you asked, but also the questions that were asked before relate to a, progression. And maybe, if we have another talk, maybe in 5 years again, maybe we could answer some of these questions, or, we'd have a clearer direction. But this is all evolving. And so I think, what you said sounds reasonable to me, but somebody would need to, look into this in detail.
Well, let's not wait 5 years, Sebastian. It's frontier is a really good way to think about this. So I do have a question, and then I also have a comment. I'll start with my comment. Some of the comments that have come from the questions now give me a lot of hope. I think there's been a lot of information about there that we should worry about the Terminator, we should worry about AI. But the very fact that you're talking about that it's up to us to train, and I think we have an opportunity for critical thinking and training people to think critically, and also an opportunity to instill ethics and the honor code, if you will. So that gives me a lot of hope. So in the time that we have left, are there predictions that you have, so we don't have to wait 5 years? But for those of us who are putting our toe into the AI world, are there practical things that we should do now so that we don't feel like we're being left behind? Is there a timeline where you can say it started in 1770, but by 2025, it's going to be a practical use for every business and nonprofit?
Yeah, you tell me, do you get use out of it? I mean, that is really, I think, the question, right? I mean, if you try it out, and I would encourage everyone to try it out, right? And if you feel it helps you with whatever task that you can outsource to an AI, I think it's great. If that's not the case, then I would not, I would not do it. I would hesitate to give hard, a timeline on it and say, all right, by this date, something is, is generally ready for everybody. I think this can be for individual tasks. So, for example, if we go back to the self-driving task, right? Okay, when is self-driving ready? Let's say, in the US or something like that, right? That's, a very specific task, and there probably we could, debate, when will that be? But in terms of these general purpose AI models, I think they will always continue to evolve. Maybe, at a different pace, like, maybe improvements will be more incremental after a certain amount of time. Mm-hmm. But even, if you think about it, a lot of it depends on what underlying data you have. And so you would need to retrain the model on the most up-to-date information, right? And so human endeavor, human research, human knowledge continues to advance. And if we don't put this into the models, then these models will not have that knowledge. And so as long as we make progress, the model also still has to learn, right? And so in that sense, this is a never-ending, endeavor.
Ethan, you have your hand up, and then I have another question from that came through chat.
Thanks there. So just in regard to the opportunities for grant writing using AI, and there's other people on this call like myself that are volunteers with the Essex Fire Department, and I've been a volunteer for 25 years. Depending on who we had on board, with or without skills in laboratories at pharmaceutical companies like Pfizer and others that have the skill to write grant requests, there are certain particulars that make them successful and other aspects that are less successful in acquiring that grant. And so, I think just looking at AI as another tool to help give guidance, for your grant writing opportunities is a good thing. And so I would say use all the tools and skills and other members of your organization that have insights into what makes grant writing successful to tap into that. Thank you.
Great, thank you, Ethan. I got a question in chat, and I'm not really sure. I'm going to ask it exactly as it was submitted, and I'm not clear exactly on what the question might be referring to. So, Sebastian, just ask if it's not clear. So the question is, how do we mitigate the effects of European-centric data sets on which much of AI is based? And if the questioner, Anna, if you're willing to unmute and sort of maybe add to that, that might be helpful.
Yep. Hang on one second.
Oh, that's fine. Thank you.
Yep. So what I was thinking of is that for those of us, especially, we've heard about AI using in hiring, or AI in other, even law enforcement applications, but there's certain biases. I mean, the data is only as good as the data. So if we're building models based on data sets that are primarily ethno-European centric, and we don't have data sets for the rest of the world or much of it, how do we make AI then work for everybody and not continue the biases that are unintentional but still inherent in the information that's already in the system?
Thank you, Anna.
I take your question to mean not so much related to Europe or the European Union as a geographical region from which data comes from, but more the kind of the ethnocentric component, I think, of your question. And I do think indeed, that is a problem, right? So any data that we feed into these models, if it is biased, then that will make the model biased, right? And I think there are various research efforts, for example, showing that facial recognition, works better for white people than, for example, for people with a darker skin color, right? So we have these biases, and I do think, I mean, the first point here is the recognition that we have these biases, and then the second point is to figure out how we can mitigate these biases. And so that could, for example, mean change something in the composition of our data set, right? For example, in the facial recognition example, that we would say, okay, we need to have a diversity of skin colors in these data sets, for example, right? So we need to work hard to identify these sources of bias and then remedy them in the data set that we use for the models to train. And to some extent that will always be a question of the time in which we live in, right? How that is recognized and how that is perceived, and what we perceive as as a bias and what we don't perceive as a bias, right? I mean, that is a notion that changes over time, but that would ultimately also need to be considered in in the creation of these models. And I do think, again, this is another task, right, where we humans have to use our judgment. This is not something that we can, just give to the machine and then the machine is telling us back, all right, this is how it is. But rather, just as the outputs, we need to be careful about. We also need to be careful about the inputs. And so I think, what I do hope is that over the long, development cycle, of these models, that also these inputs will be better recognized and better prepared, and that we will develop standards. Okay, this is data that can be put in. This is data that cannot be put in, and this is something that that goes along, actually, also along these lines, that we had discussed earlier. Not like the terms of service of a document say, okay, this can all go in, right? That's a privacy issue. but maybe it's not the way that everything that could go in actually should go, right? That's a judgment call that we also need to make. And so yeah, we need to identify this and then you know, remedy it, you know, as good as we can.
Thank you.
Well, I think we have time for maybe one more question, or if there are no more questions, Sebastian, maybe a wrap up. My gosh, I have a bazillion questions that I'd like to ask, but that's for another time, not 5 years from now, though.
Maybe even earlier.
Okay. Any other questions there?
No, I think I'm just triple checking. Abby, I think Mary, I think I've hit all of them. So I think to your point, we did hijack your presentation, Sebastian. So if there was something coming up that ties it up together, because people obviously knew right where you were headed, which was what the relationship was going to be in the near future.
Mm-hmm. Yeah. I think it seems to me, since, you know, so many questions were about a, you know, grant proposal, grant writing AI, it seems to me there's a business opportunity here. So, you know, to my knowledge, something like this does not exist. You know, if one of you, you know, wants to create it, maybe it is very useful. There seems to be an audience for that.
It sounds like the Community Foundation needs to get on this.
Yeah, that seems absolutely right to me. And so yeah, I think, you know, there isn't really a big, you know, you know, where I would say, all right, this is the big revelation that I can give here in the end. I would say this is all you know, in the making. We are in a sort of evolutionary phase, and probably you know, a lot of things will change, and I think, you know, to a lot, what I can practically say to a lot of you is really, you know, try it out, what works for you, but don't be uncritical of, you know, the results that you receive. If, you know, if it doesn't make sense to you, probably it doesn't make sense. And I don't think you should be in any way, you know, hesitant or believe, all right, this is the AI told me like this, so I believe it, you know, must be right. I do think rather maybe the opposite, that you would think, all right, I trust my own judgment here, right? I trust my knowledge, also my intuition that this is wrong. I think we would be mistaken if we would believe that this development will you know, will do this for us. So that I think, you know, is probably something that all of us, you know, can you know, consider, I think, in the future. Other than that, you know, I thank you, you know, for coming, you know, and I realize we did not get through many of these things, but you know, you have the slides, and if you want to have more information, you know, feel free to contact me, or you know, also maybe through the Community Foundation, and I'm happy to answer, you know, any follow-up question on anything really. I mean,
I'd ask to have folks come through the Community Foundation, and then we'll compile everything and send it to you, Sebastian. I have to thank you really for sharing your knowledge and expertise and your precious time with us. And thanks to everybody who was with us. So really appreciate it. And a lot of positive things, but you know what? You said it best. It's up to us.
Absolutely. Thank you again. And maybe in 5 years, maybe in 1 year, you know.
A round of applause for you. Thank you.
Yes.
Thank you.
And Cynthia, you want to do a quick reminder for everyone to keep an eye on for the next in our series?
Yes, we will be sending out, as I mentioned before, the recording. We will send out Sebastian's bio and the slides. And also on November 15th, we have Attorney Jonathan Shapiro, who is a co-chair of the Connecticut Bar Association's new committee on AI and its implications for the law. So that will, pardon me, be on November 15th. And I think it starts at 4, right, Abby? All right. Thank you.
Wonderful. All right.
Thanks so much.
Thanks so much.
Have a great evening.